All right, it's Mr. Dean. Let's get to it. We're talking about lines in the plane, all right? Slope and all sorts of stuff like that. Not talking snakes on an inclined plane or a Cartesian plane or a three-dimensional plane or snakes on any kind of plane. Here's some more jokes you'll have to pause the video to get. Moving right along, slope, intercept, form. Remember this? Y equals mx plus b. There's your beginning, or your y-intercept, and the m there is the slope of the line. So let's come up with an equation in y equals mx plus b form if they give us a point and the slope. So we're just going to take these and substitute them in where they belong. We have an x and a y already given, so we'll throw those into the equation. Just be careful to put 2 in for y here, not 6. And we have 3/4 times 6 plus b. So I'm going to think of that as 6 over 1, and I got 2 equals. Well, let's simplify. We're going to multiply now 3 times 3, multiply your numerators there. And I got 9/2 plus b. Subtract 9/2 on both sides. And 9/2 is like mixed numbers, it's like -4.5. So we'll be at -5/2, because in my mind I'm thinking of 2 as being 4/2. 4/2 minus 9/2, common denominators. And so we have our b, we have our y-intercept, so we're just going to get ready to rewrite the whole thing. Put back our placeholder of y. We know our slope is 3/4, and our y-intercept usually goes down the end like that. All right. If we're given 2 points and not given the slope, well, remember slope is rise over run, or the change in y's. Little triangles are pronounced delta y, delta x. You could say change in y over change in x. So I see 12 minus 7 over 10 minus 5. So first we're going to figure out the slope. And it looks like we got 5 over 5. Well, that's nice. Got a slope of 1. All right. And then we take that slope, put it in there, take either one of our points. It doesn't matter which one. Both points are on the line, so both will work. And I have to find my y-intercept, just like I did in the last problem. So I'm going to rewrite y equals mx plus b, but this time I'm going to, very carefully, substitute in that x and y. All right? And it's clear from here that 12 equals 10 plus b. B is going to have to equal 2. So I just want to rewrite it as y equals my slope. And of course, you don't have to write down that 1. I could skip that one and just write it y equals x plus 2. All right. Moving along. Given a table. Now remember, a table, this doesn't make things much different. A table is just a collection of coordinates. And this one only has 2 pairs, but if it did have a third pair, you just want to make sure, like, I don't know what it would be. Just want to make sure that all 3 sets of coordinates would be on the same line. Otherwise, you don't really have an equation for this. But it's just asking for those 2. So I'm going to take the change in y divided by the change in x. But instead of using any fancy formulas, I can kind of think of it like this. Whereas 11 down to 2 is a change of 2 in the y direction. And this is a change of positive 3 over here. So I'm going to rewrite my y equals mx plus b. I'm going to substitute in either one of these coordinates. I'm going to choose the bottom one and very carefully type in. And my slope is the change in y divided by the change in x. So my m is that. And my x is -3. Because if I chose 9 for y, I got to choose the same part of the coordinate there. And we have plus b. All right, well, the 3's canceled. Don't forget to leave that negative there, though. And I got 9 equals -2 times -1. That's 2 plus b. And looks like 7 equals b. And I'm going to rewrite and be done. Y equals my slope, -2/3 x plus 7. Now, if I ever want to check my work, make sure everything was working out all right, I would just go back, take any one of these, let me bring this all the way over here. Take 9, plug it in there, take -3, plug it in there. Let's just do that real quick. Times -3 plus 7. So these should be equal to us. This should actually work. That makes -1. That makes that +2. And yeah, that's supposed to be a +7. +7. Works. And there is the equation stuck down there. Now, if they give us a graph. All right, so we've got to come up with the equation. Well, first thing I think of is I will try to find the slope, and I'm going to try to find 2 points that kind of fall nicely on integers on the graph. Sometimes you can get lucky and find that. I did. So I saw that the rise over run, this looks like a rise of down 2 and over 3. All right, 3 in the positive direction, but down 2. So my slope is -2/3. Negative slopes go down to the right. And my y-intercept, so here's the problem. I don't know if that's 4.5 or not. I'm not sure if I should write 4.5. So if you do not know that it goes through exactly something on the y-axis, then we have to calculate that spot. We're going to use, it does look like that goes through right there at 4,2. So I'm going to use the slope, and I'm going to use that point. So I have that 2, that's the y-coordinate, equals -2/3 times 4, so I'm using that coordinate 4,2. The b I don't know, I'm suspicious that it's 4.5, but might be wrong. So I do a little bit of math here, let's see. -2 times 4 is -8/3 plus b. Alright, let's get common denominators, because I'm going to add 8/3 on both sides. So this 2 is going to be 6/3. And when I add 8/3 to it, let's get 14/3. All right, 14/3 is almost 5. 4 2/3. So I was close when I said 4.5, but it wouldn't be accurate. So the final equation for this is y equals. We'll get our slope, and then we'll put in. I'll put it in as a mixed number this time, although sometimes you see it as an improper. So that's how to do it, and that's a version of how to do it when you're not even sure of the y-intercept for sure. All right, now how to make a graph given an equation. All right, well, let's get rid of this. Now we know the equation, and it is in slope-intercept form. Great. That means we're gonna start with the slope. Start with the intercept, and then use the slope. And the slope here is a little bit tricky. I just want to point out that you can kind of think of it as 1/3 x plus 2. So the slope is 1/3, which means our rise over run is up 1 and over 3, and up 1 and over 3. And you can go the backwards way too. Down 1 and back 3. Down 1 and back 3. And those, get it right, should make a straight line. Now that's not the only way to talk about linear equations. You can also talk about point-slope form, which is kind of neat. There's a couple different versions of point-slope form. There's one with this minus y1 is kind of tagged on the end on this side. You might have seen that some places. But you see this just as often, if not more. Great thing about point-slope form is, you saw in the last couple of problems, getting the y-intercept was kind of tough. This one doesn't care about the y-intercept. You do not need the y-intercept. So this is as easy as writing down y minus, and let's put the y-coordinate, that's where we are here, y minus 6 equals, then we put the slope, which happens to be given, nice, then parentheses x minus, and then we'll put the x-coordinate right in there. The only little trick is that we have a minus and negative. We just got to be careful. Minus and negative is like adding a positive. So I don't like leaving that minus a positive. So I'm going to fix that. And it looks like that. So that's point-slope form. Very easy. We don't see it used as often as we probably should. It's a great way of getting equations for lines really quickly. All right, now the old debate about zero versus no slope. On the left, horizontal line has a 0 slope, right? I saw someone showed me this idea, that if you have 0 on top of a fraction, it is okay. You just have a 0. The slope is 0. So if I was to graph y equals 3, it's going to be a horizontal line at y equals 3, slope of 0. And the opposite is true now for undefined slopes. That is dividing by zero. And you know by now in math that is a big crime. You cannot divide by zero. And that you can't even get a y equals equation out of this. This is the one type of linear equation where there's no y's. It would be a vertical line. In this case at 3. All right, so if you're dividing by zero, you've got an undefined slope because it's all rise and there's no run. All right, well, last thing, parallel versus perpendicular. Parallel slopes are exactly the same, right? So if you know the slope of one, then you got 2 for 1 deal. Perpendicular lines, though, a little tricky. Perpendicular lines are perpendicular if and only if their slopes are negative reciprocals of each other. So a little fancy, let's talk about that. So if the slope of, say, line 2 here looks like pretty steep, let's say it's 4, then the slope of the perpendicular one is the negative of that, and flip 4 over to be negative 1/4. All right. In a different example, let's say you had a negative 2/3 as a slope, and you want to know what's perpendicular to that. That's a little symbol for perpendicular. Parallel slopes have that line. Perpendicular to negative 2/3 is positive 3/2. Another thing that's kind of neat is if you multiply slopes of perpendicular lines, they will always equal negative 1. Well, that is the end of Snakes in a Plane. See ya!